Hello and welcome to FastTrack for Azure's Infrastructure as Code session. Today myself, John and Victor are going to be looking at all things infrastructure as code and how you can automate your Azure environment. Typically when people start working with Azure for the first time, they use the portal. And while this is great from a learning perspective, as soon as your scale requirements get larger than managing a few resource groups, things typically tend to get out of control pretty quickly. So in today's session, we're going to look at all of the many benefits of IAC. And in this section particularly, I'm going to describe some of the reasons why you would adopt infrastructure as code rather than manually creating things through the portal. And John and Victor will show it how to actually do this. So what is infrastructure as code? It's a way of describing an environment in a machine usable format. And as well as machine usable, these configurations should be human readable. And when we talk about infrastructure, we don't just mean infrastructure as a service, say VMs, networks, and storage. We can also automate every other aspect of every other resource inside Azure, such as paths and serverless resources, functions, logic apps, etc., networks and config, even access control policies, and even database objects, and every single configuration of every type of resource you could think of in Azure. Infrastructure as code comes in two distinct flavors. So the first is an imperative approach, and the second a declarative approach. And these are two, broadly speaking, two categories of IAC tools. The imperative approach, you issue commands, typically scripts or programs, that have to handle all eventualities. So their dependencies, errors, upgrades. They have to be conscious of idempotent. So, if something's set in the correct way, and then you apply that configuration again, it shouldn't error out. It should handle that fact and gracefully carry on. So there's a lot of focus on the end user having to think about all of these issues and code around them. And it obviously becomes harder and harder as the team grows and things get passed between different owners. They have to pick up on all of the idiosyncrasies and all of the challenges that have been built and the style that's been used to create the scripts or programs. Whereas the declarative approach, you describe the end state, what you want, and Azure figures out how to do it. And this is far more easily understood by new operators and really creates a much safer and more consistent way to create resources. So there are many, many tools and processes that can be adopted for infrastructure as code, but really they're there to support your company and your level of maturity. So typically when we engage with Azure customers, especially those customers moving from on-premises, the process is either completely manual or there's partial automation. Some assets are automated, some assets are created manually. Level 2 that we typically see is IAC assets are all created programmatically, but humans still have a need to access those environments, particularly a production environment. You'd see that many people would have read-write access to that environment because a lot of the supporting operational activities themselves aren't automated and are very much manual. The third level of maturity that we see is, like level 2, all IAC assets are automated, but there is no human access to an environment except in a dire emergency. So let's take a look at how a typical workflow might occur. So first, a developer or an operator writes an asset, and Victor will talk about this shortly. They'll commit that asset into a source code repository like Git, and once that asset's been committed and then merged into the code repository, there may be a review process where that change is merged and a separate person reviews that change and validates that it's actually not malicious and it does what it's intended. And once that reviewer is happy, that change is merged and a pipeline may then ensue. So typically this would involve a build phase and a release phase. That release phase would actually create the resources in Azure. So really the whole point of the infrastructure as code approach is to allow you to gain more confidence in your deployments. Integrate with your current team's processes, follow a consistent process, and scan your assets automatically for vulnerabilities or misconfigurations before they actually hit the environment. So let's have a look at this process again and see how this might work. Let's zoom in on the build phase of the pipeline. So typically this is something that's a concern of developers. They're responsible to write the code and write tests for the code. The build pipeline stage does exactly that. It builds and runs unit tests on that code and then finally packages it up as a deployable artifact that can then be deployed across many environments. We can actually add a similar approach for our IAC assets. So we can lint them, so we can make sure or ensure that they're syntactically correct. And we can also scan those IAC assets for known vulnerabilities, known misconfigurations, whether people have hard-coded passwords, secrets, credentials, that kind of thing into those assets. That can all be caught in the build pipeline. And if they're found, we can fail the pipeline so that the artifacts are never released. And this is something that comes up time and time again with people deploying things from their laptops. They may have secrets locally. They might actually embed secrets in these asset files. So security is top of mind these days with most customers, considering the number of breaches of on-premises environments. So now let's have a look at the release part of the pipeline. So in Azure, these secrets can be stored securely in a vault. Those could be simple plain text passwords, they could be cryptographic keys or certificates. And most IAC tooling, so the pipeline, will integrate nicely with Key Vault so that the people writing the assets don't actually need to know these secrets. These secrets are accessed on demand, just in time from a Key Vault by the pipeline. So the pipeline has the access to these credentials and these secrets stored in Key Vault, which can be preceded by a separate security team, which creates a nice separation of responsibility and means that the assets won't be, or the secrets won't be, misused or unintentionally leaked. So while we're talking about security, it's worth going back to that third level of IAC where humans have no access to these environments. So in many organizations, an operator has read-write access to the final production environment, which causes some issues for infrastructure as code, especially if you're using an imperative approach. The state of the environment may not be that what is expected by the script, and it may fail. So one way of combating this is to remove write access for operators from the production or even the UAT environments. We don't really want humans changing things on a day-to-day basis. But there still may be exceptional circumstances where an emergency might happen and we absolutely need to make a change instantly. It can't be added into the pipeline as code and pushed out, propagated by IAC. So there are two main approaches that we recommend for this scenario. The first being a break glass account. So a lot of organizations follow this. They may even just have separate accounts for admin access and standard read-only access. And there may be a third account that's highly privileged where The password for that account is stored in a physical vault, for instance. I've seen customers do that. And this account sits dormant. But in emergency, an operator can get access to it, get the credentials, and use it to access Azure. And this works well, but there is another option that's provided by Azure Active Directory called Privileged Identity Management. So you can configure this to allow just-in-time access. So what this enables really is no standing group membership to highly privileged accounts. That group membership can be enabled on a time-based level, so you can get access for 1 hour, 2 hours to this privileged group membership. And the group membership can also be reviewed by upper management or your peers. So there's an audit trail of who got what access when and exactly what they did. I mean, this is a really good option because it's enough of a barrier to stop people doing this on a daily basis, but it's available as a secure option when you really need it. Another way you can gain confidence in your deployments is by avoiding configuration drift. So removing human access means that things only change when the pipeline runs. So your IAC assets become the source of truth, and it means you have much more confidence in your deployments as you can run those exact same assets through dev, test, UAT, prod environments and be pretty confident that the environment that you're deploying to is the same as the previous one. Automating also allows you to manage multiple environments. So you can have multiple non-prod and prod environments that look exactly the same. I mean, of course, you could have different scale on these different environments. So your prod environment would scale higher and have maybe higher amount of compute resources, storage, etc. But other than that, you should be using the same templates with different input parameters to define those different environments so that you can be sure that these environments are configured the same and therefore your testing actually means something. It also allows you to dynamically provision new environments. So you can create demo environments, test environments. Some clients even go as far as automatically creating a new environment on a pull request. So a developer does a pull request, or an operator creating an IAC resource does a pull request on the repository, and that pull request creates an environment using those assets and validates it. And if it passes validation, deletes the environment. And if it doesn't pass validation, also deletes the environment and notifies the person that made that pull request that it's failed. Also allows you to scale your environments. So you may have different instances in different geographic regions or different customers on different gold, silver, bronze type plans, and they may have different scaling environments. So using IAC and just adding parameters that are input into that template that decide the scale of the environment makes adding more environments very, very easy. This also supports disaster recovery. If you think about it, all of your assets are now stored in a code repo, they're versioned, and by a simple commit or a click of a button to initiate a pipeline deployment, you can deploy that to anywhere. So in a disaster, you could deploy that to a completely separate Azure region. And you've got high confidence that that deployment will work because it's been tested in many other environments and no human has had to manually click around in the portal and potentially make a configuration mistake. Also, since every single operation that's made on Azure occurs via one of Azure's APIs, the Azure Resource Manager API, all changes to your cloud environment are audited in the Azure audit log. So you can trace back and see who made a change when and line that up with changes in your IAC code or your application code and see exactly what caused an issue. And then record that fix for that issue within the repo. And forevermore, you've got those learnings baked into your repo, and you accumulate knowledge and fixes programmatically without having to store that in somebody's head who may not be around when disaster strikes. Using infrastructure as code also allows you to keep metadata and documentation alongside your configuration, and version and keep those logical changes together in a repo. Also, doing things programmatically allows you to better understand Azure and the interaction of its different components as well. So hopefully those benefits are enough to convince you that IAC is worth doing, especially once you get to that level 3 of the maturity model.
Thank you, Chris. Hi, everybody. Chris has just given you a really good explanation of why infrastructure as code is so important. And now I want to start talking about how you can actually start using infrastructure as code with Azure. So I've got Visual Studio Code open here, and I'm going to be using Visual Studio Code to write some Bicep code, which is, Bicep is the language that we recommend that you use if you don't already have something that your organization uses for infrastructure as code on Azure. Now, when you start working with Visual Studio Code and Bicep, one of the things you can do is install this extension, which is the Bicep extension for Visual Studio Code. We'll be using that today, so if you want to follow along, feel free to grab that and pause the video and come back when you've got that installed. So Chris has already given you the basic overview of how you create resources in infrastructure as code. You define them using a declarative or an imperative syntax, and then provide them to Azure to deploy. So we're going to do that now. So we're going to start with a really, really basic Bicep file, and then add progressively more complex Bicep features to it to kind of see how this works in the real world. So what I'm going to do first is I'm going to create a new file, and I'm going to call it main.bicep, which by convention is the name of the Bicep files that we tend to create. So when I want to actually start creating resources, then here's an example of how I can do that. So the first thing I can do is tell Bicep I'm going to create a new resource. You can see as I type, the Visual Studio Code extension gives me some tips and some hints, and we'll look at those in a bit more detail shortly. I'm going to give this resource a name, and I'll come back and talk about names again in a second. And then I need to tell Bicep what kind of resource it is. And in this case, I'm going to create a storage account. Now, every resource in Azure has an API version, and actually most resources have many API versions. Generally speaking, Bicep will suggest we use the most recent version so that we get all the latest features of each Azure service that we're using. So I'm going to do that here. Now, in my Bicep code, I can then say I'm going to create a storage account with this particular name. And again, I'll come back and talk about this in a few minutes. I have to tell Azure where to store it. So this is actually where the resource is going to be deployed in the world. I'm in New Zealand, and the closest region to me is Australia East. So I'll put it there. And then I need to specify the SKU. Now, the SKU basically means the pricing tier, or the type of resource that we're creating for a storage account. Storage accounts have multiple different SKUs that we can use. For this one, I'm going to use the cheapest tier, which is the LRS tier, which means locally redundant storage. Now, as I'm typing this, you can see that the Bicep extension for Visual Studio Code has propped up with this thing called required properties. It understands that I'm starting to type in a SKU, and it's going to give me some hints about what that might look like. So in this case, I'm going to say, well, the SKU name is this standard LRS. And again, you can see that the Visual Studio Code extension is helping me to type this as I go. So I'm going to say this is a storage v2 account, and I'm going to give it some properties, which is kind of all the other stuff that we can configure on our Azure resource. And in this case, I'm going to say the access tier is hot. Now, you might not necessarily understand all of the properties I've just set. That's okay. But the key point here is that we've now defined a complete Azure resource. So that resource has all sorts of information that Azure can use to deploy it. And if we redeploy it and haven't made any changes to the resource definition, then Azure won't create a new storage account. It will just look at this storage account that's already there, compare the properties, compare all these settings that we've configured, and update them if it can. Okay, so I mentioned that there are two different names here, and I want to just drill into that a little bit more detail. So the first name is the name that actually appears in Azure. Now, for a storage account, all storage accounts need to have a globally unique name. We'll look at a better way to do this shortly, but for now, I've just mashed on the keyboard a bit to create a storage account name. So this is what will actually appear in the Azure portal shortly when we deploy this file. We've also got this other name here, which is what we call the symbolic name. And the symbolic name is only how we refer to this within the Bicep file. We can call this whatever we want. I've called it storage account, but we could call this, Mickey Mouse if we want to. It doesn't matter. And this name will never appear in Azure. So all we're doing here is giving us a name that we can use within our code so that we can find this particular storage account. This is really useful if you're going to have multiple storage accounts of different types or for different purposes. You can give them a symbolic name that's meaningful to you, and then when you're using it within the Bicep file, you know exactly which one you're dealing with. Okay, so we've now created a really basic Bicep file that creates a storage account, or that defines a storage account. So I'm going to use the Visual Studio Code terminal. And what I'm going to do is use the Azure CLI to deploy this Bicep file. So I've already created a resource group. So I'm just going to say AZ deployment group create. So what this is doing is saying to the Azure CLI, create a new deployment to a resource group. And the resource group name I want to use is Bicep Demo 1. And then the file name that I want to use, I'll just paste in this file name here. So that'll take a few moments for it to submit the deployment. Bicep validates that everything looks correct, and then hands that Bicep file off to Azure, and Azure will then try to actually deploy it. If there's a problem, we'll get some information back telling us exactly what that problem is. Now, I've got the Azure portal up here, which I'm just going to open up at the moment. And this is the resource group that we're deploying into. So if I refresh this, nothing is showing there now, but if I look at the deployments, you can see that there is a new deployment here, and this deployment state is deploying. I can click on the deployment and I can actually see that this storage account that I just defined with that name has been accepted. In other words, that deployment is in progress. Now, generally speaking, for storage accounts, deployments are very quick. As you can see, that's now completed. For other resources, it can take a bit longer. And if we look in the Azure portal, in a moment, it takes a few seconds for the portal to refresh. In a moment, we'll see the storage account there, and we can start using that storage account as a normal storage account. There it is. So we've just defined a really basic but very functional Bicep file that creates a storage account. Now, in this particular example, what I want to do is show a few more features of Bicep that are a little bit more complex than just a single storage account. So we're actually going to add in another resource now, and I'm going to bring this terminal all the way down so we've got a bit more space here. So this time I'm going to create a resource called an app service plan. And the app service plan, if you're not familiar with app service plan is essentially the hosting infrastructure. It's like the server that runs a web app. So what I can do here is look for server farms, which is the internal resource name for app service plans. Again, I need to choose an API version, and then I can start defining the resource. And for this, I need to give it a name again. So I'll call this my app service plan. I need to give it a location, and again, I'll put this in Australia East. And then I need to specify the SKU. And this time I'm going to create a SKU with a particular name. So I'm going to use the F1 tier, which is the free tier. And capacity, which is how many instances of our app service plan do we want. I'll just say 1, which is all you can have with the free tier. So that defines an app service plan. But what that doesn't do is actually give us an app service to look at. So let's add in another resource, which is the app service app. Now, if you're not familiar with app service, an app service app is the actual application that you can access. That's a website or an API or something like that. you can have multiple app service apps hosted on the same app service plan. So you link those two things together. You link a plan to an app. Now in this case, I'm going to look for Microsoft.web/sites. And I've just screwed up the formatting there, so I'll just fix that up. And the API version that I want to use, I'll use the same one as before. Visual Studio Code did actually try and help me with that, but I interrupted it by trying to be too clever. And what I can do here is give this a name as well. And app service plans don't need globally unique names, but app service apps do. So for now, I'm just going to copy this name that I've used here. And again, I need to put that in a location, so I'll use Australia East. And then I need to specify some properties. So the main property I need to specify is the server farm ID. That's the app service plan that this app should run on. So you can see there's a dependency here between these resources. The app service app needs to know the app service plan's details, and also the app service plan needs to be deployed before the app service app is deployed. So let's try doing this now. We'll say we want the server farm ID to be the app service plan.id. So that's the resource ID, the unique identifier for the app service plan that we've defined here. And we can also set another property here, which is HTTPS only, which is usually a good practice. Okay, so we've now defined a Bicep file with 3 resources. So we've got a storage account, an app service plan, and an app service app. If I redeploy that same Bicep file using the same command as before, and then we can look in the deployments and see that that deployment has been accepted. And we can refresh this and see as these resources are being created. So the app service plan has already been created, and we'll see the app service app pop up in a moment as well. Now what Bicep has done behind the scenes is, because it understands that dependency between the app service app and the app service plan, it makes sure it deploys this first. It doesn't try to create the app service app until the app service plan is done. If there's a problem with the app service plan and it can't create it for some reason, then it won't create the app service app. So we can see the deployment's complete. I can look at the details and see the 3 resources there, the Microsoft.web/sites, server farms, and storage account. And if I go back to the portal and look at the resources, I can see the app service and the plan there. And of course, because this is just an app service like any other, I can actually open this up in my browser, and this is a valid app service application. And there we are. So you can see you can create quite sophisticated deployments using Bicep. And in fact, pretty much everything that you can do through the portal, you can do through Bicep. Some things are easier than others, but you can achieve everything that you need to do using infrastructure as code. Now what we've done here is we've created a basic Bicep file with these 3 resources, but we haven't done a very good job of making this Bicep file reusable or well structured. So we've done things here like we've hard-coded the names of our resources, which means that if we try to deploy this somewhere else, that will fail. Because these resources need to have globally unique names, we can't use this to deploy another copy. So we're going to fix that in a second. We've also got some duplication here. We've got the location defined 3 times, and if we needed to change the location for another deployment, that would be a bit of a pain to have to go and do a find and replace. We've also hard-coded some things like the SKU of the storage account and the SKU of the app service. And again, if we're deploying to multiple environments, we might have different requirements. So for example, when we deploy to non-production environments, it might be perfectly fine for us to use LRS storage accounts because they're cheaper. But when we deploy to production, we might need to use either ZRS or GRS storage accounts because they give us more reliability, more resiliency, more availability. So we're going to go and fix those now, and we'll have a look at some other Bicep features that help us do that. So the first thing we're going to do is change the way that we define the names. So what I'm going to do is create a thing called a Bicep parameter. And a parameter is an input to the Bicep file. Okay, so what we can do is we can create a parameter here called storage account name. We have to tell Bicep what kind of object it is, or what kind of parameter, and that will constrain whoever's going to be using this template to make sure they enter the right kind of value. And we can also set a default value. And for the time being, I'm just going to use this value here. Now I can then say that the storage account should take its name from that parameter. Now if we deploy this Bicep file without explicitly specifying a parameter, that's the name that it will get. that's still not a great name, or we'll fix that again shortly. But you can see here that now we've already made our template a little bit more reusable because we've now got our name is defined as a parameter. Now I'm going to do the same thing for the app service app name. And again, I'll cut this out of here, put it here, and then refer to that parameter down here. Now in this case, I haven't done this with the app service plan name because the app service plan name is it does not need to be globally unique. But it's still a good practice to declare them somewhere central. Even if you're not going to have it as a parameter, it's still a good idea to declare all the names together. So I'm going to create the app service plan name here. And with a variable, I don't actually need to type in a type. Bicep can figure that out all by itself. So I'm going to put that there and then say this is the app service plan name. Okay, so now we've got all of our names. We're following best practices, or close to best practices anyway. We've got the names for globally unique resources being passed as parameters with default values, which we'll talk about shortly. And we've also got the app service plan name being defined in one place. Now what we can do is deal with the locations. So here, all of our locations are the same. So we can again create a parameter and use that parameter to set the locations for all of our resources. And of course, when you're creating these templates, you normally start with doing this. I've gone it the other way around just to kind of build things up slowly. So we've created a location parameter and we're using that throughout our template. Now, one of the things that we want to do here is this location parameter is currently hard-coded to Australia East. And that works well for me personally, but for other people, that's probably not going to be where you want to deploy all of your resources. What we can actually do is use a feature of Bicep called language functions and language expressions to automatically figure out some of these values. So for example, when we want to set a default value for the location parameter, what we can say is we actually want that to be the location of the resource group that we're deploying into. So this resource group, whatever resource group we're deploying into, has a location. And by default, if we don't otherwise specify it, then Bicep will take that location and it will use it as the location for our resources here. Now we can use the same kind of thing to also set globally unique names for our storage account and our app service app that don't require us to mash on the keyboard and hope that we find something unique. So what we can do here is we can use a function called unique string. Unique string gives us back, as its name suggests, a unique string. And that string is going to be the same every time we pass in the same arguments, but different if the arguments are different. So what I mean by that is let's take the resource group ID. Oops, I've misspelled resource group. So the resource group ID is the resource group name plus your subscription ID plus some other information. And it's a really good candidate for unique values like this, because what this means is if we deploy the same template into the same resource group over and over again, we'll get the same unique string back. And so we won't be redeploying new storage accounts all the time and new other resources. But if we use a different subscription ID or we use a different resource group name, then the unique string will give us a different value. And so then it will make sure that each of those deployments has different globally unique names. But what we can do here is this unique string is going to give us a name that's not particularly meaningful. So what we actually want to do is combine that unique string with something that's a little bit more meaningful. And we can use Bicep string interpolation to do that. So let's say, for example, we want our storage accounts to all start with the name store. What we can then do is use this funny expression here, so the $, and then open and close curly braces, and inside those curly braces, we just put the function that we want to run. So this is basically telling Bicep the name of the storage account by default should be store, followed by a unique string that is set up specifically to be unique for this resource group. We can use that same approach down here, and we might say, for example, this is app. Now, the thing to remember as well is these are parameters. So if somebody wanted to deploy this and explicitly set their own storage account name, they wanted it to be something very particular, they can do that. But if they don't specify a storage account name, then they'll get this behavior here. Okay, so we've now created a fairly reusable Bicep template in terms of its location, in terms of the parameters, and we're using a variable here as well. But what we haven't done yet is dealt with these SKUs. So we're gonna sort that out now. Now, I mentioned before that the business logic that we might want to use in our template here is that for non-production environments, we want to go with very cheap resources. So things like LRS storage accounts and F1, which is free app service plans. But when we come to production, we want to go with much more resilient and performant SKUs for resources. And this is a fairly common requirement. So what we can do is we could specify some logic in here to try and figure this out. And what we're going to do is create a new parameter called environment type. Now the environment type is basically going to tell us whether we're deploying to a production environment or a non-production environment. Because we want this to only be one of those two values, we only want to be production or non-production, we can use a feature in Bicep called a parameter decorator to constrain the values that we're going to allow for that parameter. So we're going to use the allowed decorator here, and I'm going to say we can have non-prod and prod. What this means is that when somebody deploys this template, they need to specify the environment type string to be one of these two values. If they try to specify it to something else, their deployment would fail. Now what you can see here as we're going, just as an aside, is this yellow squiggly line underneath environment type. As we're typing our Bicep code, the Bicep Visual Studio Code extension is actually scanning it and checking to see if we're following best practices. And what it's discovered is currently there's nothing using this environment type parameter. So if we hover over it, it says parameter environment type is declared but never used. So we're going to fix that shortly, but it's worth just keeping an eye out in your Bicep code for any red or yellow squiggly lines like this, because they indicate that you might want to have a look at what it's suggesting. Okay, so we've got an environment type, and I'm going to set the default value there to be prod by default. But then what we need to do is figure out, well, we know what kind of environment we're deploying. How do we turn that into a SKU, right, for the storage account and for the app service plan? And what we're going to do here is we're actually going to create another variable that will do that mapping for us. So what we can do here is say we're going to create a new app service plan SKU name variable, and we're going to use something called the ternary operator, which is basically like a little if statement. So we can say if the environment type, oops, I've got the equals on there, if the environment type is equal to prod, then we want the value of this variable to be p1v3. Well, actually, let's make it t2v3 just to be more realistic. But if it's not if the environment type is not prod, then we want it to be F1 like it is now. So we put a little bit of logic in our Bicep template. So we've been able to say, look at this parameter value, and based on its value, then set the SKU name that we're going to use. And then down here, of course, and here we can then just use that variable name. And you'll see now that all of those red and yellow squigglies have gone away because we're now using all of our parameters and variables. Now we can use the exact same approach for our storage account. So for our storage account SKU name, again, we'll say if the environment type equals prod, then we want to use the standard GRS tier. But for non-production accounts, we want to use, or non-production deployments, standard LRS like we're doing now. And as before, we can now replace that here. So you can see that by doing this, you can start to embed some of your business logic right into your Azure deployments. And that means that whenever somebody deploys these resources, they're going to get that same behavior, which is one of the really big benefits of infrastructure as code that Chris was mentioning before, is that you get these repeatable, consistent deployments, but you also can encapsulate your business rules and make sure that everybody's being consistent. Now, we could, of course, do the same thing with the capacity. I'm not going to worry about that right now. Actually, why not? We'll do that as well while we're here. And let's say, for example, we want to say the environment type is prod. And if it is, then we want to use a capacity of 3. Otherwise, we want to use capacity of 1. So we can put this down here. Okay, so we've now done a pretty good job of creating a reusable Bicep template that follows a lot of best practices. But I want to show you another couple of features that really help to make your Bicep templates even more capable and capable of doing some more complex deployments and more reusable as well. So we're going to start by using a thing called modules. So in my folder that I've got here, I'm going to create a new subfolder called modules. And within that, I'm going to create a module called appservice.bicep. Now, looking back at our main Bicep file, we've got a bunch of different things going on here, right? We've got the storage account, and we've got some stuff related to the storage account with these variables and parameters. And we've also got the app service related resources and all of their parameters and variables as well. And you can imagine as you start to get more complex deployments with a lot more going on, then the number of resources and the number of parameters and so forth gets quite large. So what we want to do is move all of the app service related stuff into this app service module, which is itself a Bicep file, just a normal Bicep file, and then we can link to that from our main Bicep file. This means that we've got some nice benefits, right? So the first one is that we keep our main.bicep file a bit neater. We don't have it kind of mixing up all of the details of all of these different resources together. But also it means that we've got a reusable app service Bicep file that we can use across multiple other templates. So we can create a library of these app service or all of these modules and then use them across lots of deployments. So let's do that now. So we're going to move these resources into this app service.bicep file. And you can see as soon as I move those resources, a lot of the parameters and variables that we're using are not present in this file. So we need to fix that up before we can go any further. And again, the Bicep tooling you can see with all of the red and yellow squiggly lines is really helping us to do that. So what I'm going to do here is cut across these variables here because we don't need those in our main.bicep file. We only need them in this appservice.bicep file. And then I'm going to copy across the location parameter. And I'm going to copy across the app service app name parameter. And we'll see how we set these in a second. I also want to copy across the environment type parameter. Now, as soon as I've done that, you can see that all of the problems in this file have gone away. And we've now got a Bicep file that hopefully should deploy our app service app. What we now need to do is tie this into our main deployment. So just like we did before when we created a resource definition, we're now going to create what's called a module definition. And I'm going to call this module app service. And we say this is the file name we want to use. And we have to give the deployment a name. So the modular names, this becomes a sub deployment, which I'll show you in the portal in a minute. And then we can specify the parameters for that module. And I'm going to just pass through all of the parameters that we're using in this main.bicep file. So I'm going to say the location is the location parameter. The app service app name is the app service app name parameter from here. And the environment type parameter should be the environment type we use here. What this also means is that these default values in this module can probably go away. Because we're not going to be using this module directly, we're not going to be deploying it directly, it's better for us to be explicit and set these in the main.bicep file. That's just a style choice. That's my personal preference. You might have your own way of doing things as well. Okay, so we've now got a really nicely structured set of Bicep files, right? We've got this main.bicep file that drives our deployment. It also deploys a storage account because that's just a single resource. We could put that in a module if we want to, but there's probably not a huge amount of reason to at the moment. But then the app service components are all declared in this appservice.bicep file. So if we deploy this now, I'm actually going to deploy it to another resource group, Bicep Demo 2. And what that will do is it will create, in fact, I've got this resource group here. So it's creating a deployment. And if we wait for this list to update. There we go. So the main Bicep file deploys first. That also then creates this app service deployment as well. And if we look back here, we'll actually see that there's a new deployment. So each module in our deployment gets, in our Bicep file, gets its own deployment here that we can look at separately. But they're all tied together and from that one single Bicep file. You can also see that even though that app service deployment is still underway, Bicep has actually started deploying, or actually now finished deploying, the storage account. Because there's no dependency between those two resources, Bicep knows that it can deploy them both in parallel, and so it can save a bit of time by doing that. So wherever possible, Bicep will try and deploy things in parallel, and it'll only deploy things sequentially if there's dependencies. So we can see that both of those deployments have succeeded. And if we go back to Visual Studio Code in a moment, there we go. All of the information is shown there about the deployment we just made, and it was a successful deployment. Now there's one more thing I want to show you, which is that you also often need to get data out of your deployments. So let's say, for example, that in your app service deployment, you need to know the host name of the app service app. So that's the how you get to it in your browser. So what we can do is we can create a thing called a Bicep output, and I can call this app service app host name, and I can then say that that value needs to come from the app service app properties, and it's called the default host name. Now you'll see here that the properties that we've got available to us for outputs are different to the properties that we set. So when we create this app service app, we can't set the default host name. That's set by Azure itself. It's created by Azure itself, and it's available to us here because it's created after the resource is deployed. So it's a read-only property. Now what we've done here is we've created this output from the module. So if we were to deploy this, then if we look in the app service deployment from the portal, we would see that that output was present. But what we probably want to do here is actually flow this output through our main.bicep file. And this means that whenever somebody executes this deployment, like I did now manually, or does it through a pipeline, they'll see it as well. So we need to create another output in this main.bicep file, which we'll call the same thing. And this time we want to take the output from the app service module. So we use the outputs and we have the app service app hostname. Let's deploy that again now. And so by doing this, we're resubmitting the same deployment. Of course, Azure's not going to redeploy everything. It's just going to look at the information that we've provided and say, we've already created this resource. We're not going to have to recreate it or delete it or anything like that. And if we look in the app service deployment, we can see the outputs. We can see the app service app hostname is here. And if we look in the main deployment and look at the outputs, we can see the same thing there because we've flowed that through. Now this is really just scratching the surface of what you can do in Bicep. So we've covered this. We've covered lots of different features of Bicep. There's actually a lot more that you can use to create really sophisticated deployments. So what I'd suggest is, if you are interested in learning about Bicep, we put together a whole lot of content on Microsoft Learn to explain how Bicep works and to really go into the detail of what we've done here today, and then to take it a lot further as well. That also covers some of the pipeline related content that Victor's about to talk about too. So if you're interested in that, the link for it is aka.ms/learnbicep. And that will take you to this page here, which is actually on our documentation. That will open up the Microsoft Learn content, and you can see here there's all sorts of information which covers a lot of the stuff that Chris talked about before. Why would you use infrastructure as code? What we've done today is pretty much follow this content here, so looking at some of the basics of the Bicep language. But then you can see there's a lot more detail here around all sorts of different things you can do with Bicep. And there's actually even more content than we've got available on the screen here. So with that, I'd now like to hand over to Victor, who's going to be talking about how we take that Bicep file that we've just created, and those Bicep files, the module and the main Bicep file, and how we automate the deployment of that by using a deployment pipeline.
Thanks, John. Now, what you just saw, that you saw John just show you how to deploy the Bicep, create a Bicep, deploy the on template using the Bicep template, and doing that manually with the Azure CLI. Now, what I'm going to show you is the next step on how to automate this. So turn that infrastructure as code into a CI/CD pipeline. So what you need as a next step is to check your code into a Git repository. So it can be, in our case, it'll be GitHub, and it can be any Git repo. So it can be Azure repos, it can be GitLab or Bitbucket. So whichever flavor or Git repository or repository your companies use is fine. So what you want to do is you want to make sure that you have the your deployment, which is your Bicep uh, files, the Bicep file and the modules in here. So we have a main Bicep and we have a module which is app service module, right? And the next things that you can include in here if you plan on to deploy your application along with your infrastructure. Uh, so you can include your application source here. So there's an application folder in the example here as well. All right, and how we create a pipeline. So there's several orchestrators out there, and we choose to use Azure Pipeline as an orchestrator. So you can select to using like something like Azure GitHub Actions, which is GitHub workflows, same thing. So the pipeline is pretty much a orchestration where you define the steps of what's going into the pipeline or the workflow. And with that, you create it using YAML file format. So I can show you this in an example. So within that YAML, you got the trigger, and trigger usually either the repository, or you can do it manually, or it can be a timestamp, so like a time trigger. So with this, we target a specific branch in the Git repo, which is main branch here. Uh, as you can see within the step of it, you get stages, you get jobs, and you can choose to get jobs to run parallelly. That's not on by default. Typically, there's just a sequential, and you run one job at a time. But with the proper configuration in Azure Azure Pipeline, you can have multiple parallel job running at the same time. So I'm going to go through a scenario here where, let's say, your dev teams currently we deploy 2 instances of app service in a production environment, but now that they want to increase that from 2 to 3, so what we're going to do is we're going to go in here and change the module where it's deploying app service and change the number from 2 to 3. All right, so let's edit this. We change the number 2 to 3. So in this case, say if the environment type is production, I'm going to deploy 3 instances of app service. That all this thing saying. So we say change production instance of app service from 2 to 3. Commit it. Now, like I show you and explain to you earlier, the trigger here is based on the commit of the new code. So since we made the change to the Bicep file, now it's kick off the pipeline. So now if I refresh this, you start seeing that the job has started to queue, and now it will kick off shortly. So let's walk you through some of the steps, what we do inside the CI, which is continuous integration, or you can call it short for build pipeline. right? So let's look at the one that already complete. So in here, there's two jobs. One is build Bicep, which build the Bicep file, and the other one is build the apps. So since we have both Bicep, which is for IAC, and the apps compilations build step here, so we're doing this in parallel together, right? As the Bicep built, the application also does a compile and build at the same time. So I just want to focus on the Bicep for this demo purpose. So as part of that, what we do is we built the ARM template. So how we do this, we're using the command line to execute the build template, and you can see that there are logs that showing up in here. So build the ARM template, we're using Azure CLI to do that. So we're using a PowerShell here to do, and the command you can see it's using the PowerShell here. So build an ARM template from Bicep file, right? And then when we're done with that, we copy the ARM template file to the artifacts working folder, and then publish the ARM artifact to that part of the pipeline to be an artifact so that we can use it later on in another pipeline, right? So that's what it is. So if I show you jump back to the code, jump back to the pipeline definition, which is written in YAML in the CI. If you look into this, so there's a PowerShell here. So this is how we build the ARM template from Bicep file using Azure AC Bicep build, the name of the file, the file path, and the name of the file. All right, and then we do the copy file and then publish artifact as I show you in the log. Now we do the same thing. So when the build's done, the CI is done, it will trigger the CD, which is continuous delivery. This is where the ARM template that was converted from Bicep get lint using. So what we do is we can lint it. We can using what if, then the validations and things like that in here to make sure that the change is going to happen is been validated, and we know that what's going to change. And what we do as part of it is that we also have approval process that's sort of built in here. So the approver had to review the Bicep or the change that's going to happen first, which is going to be determined by the what if command. So if you look into the code here in the continuous delivery, we're using the template, right? So we have an IAC release template and the app release template. So again, we're going to focus on the IAC release template. So if I jump back a little bit and show you the template, right? In the IAC release, we can see that I'm downloading the artifact that was published earlier from the build or the CI process, and then we'll run the Azure CLI to check the what if. So there's a deployment what if. So what this does is that it checks that Bicep template or the ARM template that built from the Bicep and checks again existing resource group or the resource group, this one that's already been deployed, and see what's looking for the delta basically, and you'll get that as part of the result. And then when it's done, it's going to do the deployment. So the deployment we're using, we download that artifact from above. And then we're using Azure Resource Manager template deployment to do the deployment of the template. and that's the build process. So if we jump back into the pipeline and let's review the CD, the continuous delivery portion. So let's look at the one that is running still, so we can look at the step process involved. So we have multiple deployment stages here. You can see that just one single job, there are several jobs happening, but they have 6 different stages. So you can see that there's a validation, which is the what if, right? So we do the download of the template and look at the what if, and you can see in here that there's a result of the what if. So there's a 2 modify and 1 no change. So you can see that what's going on here. And from that part, we do the same thing, and then we do the compile and download the compile, then do the Azure Resource Manager template deployment. And this is where you deploy the actual JSON file, which is the ARM template, to the against your resource group. Now, at this point, we just deploying it to non-production or not a production one, right? So it can be test or dev environment. I hit refresh here. So this is a resource group that we deploy for a non-production, and you can see that there's a product, which web apps, the app service plan, and a storage account. So we click on this. The application has been deployed as well. So we should be able to browse to the application. And you can see that it's working. All right, so now that it's validated, now I'm waiting for this to happen. So if I click back a little bit here, now you can see it's waiting for me to do approval. So you can see the stage here is waiting. So I click on the wait, and it's asking me to review. So I'll say approve needed your review before this run can continue to deploy to our infrastructure, right? So we need to review the pretty much the the what if, right? So before we do that, so I'm just going to do is I'm going to go check on the what if. So let's look at the validation. So that's the validation step and what if. So again, we can see that's 2 to modify, 1 no change. So what's this going to be modified? SKU capacity went from 1 to 3, right? And that's what's going to change in the plan. And also site configuration also consider changing as well. So let's look at that. So this one is a modify. If you look at the symbol, so modify, create, no change. So this is no change. To modify, so the modified version of it is the capacity and the configuration, which we didn't change it, but that's sort of false positive here, false negative here, but that's fine. But we know that this is what we want, so we keep it that way. And so what we're going to do is just going to go ahead and approve this, click approve. So when I click approve, then the process will continue. So otherwise it will, it's wait for extended period of time, and then it will time out. So how did I do this? So within the pipeline here, I have a environment. So what we do is that we deploy this against an environment within the Azure pipeline, right? So the environment that we're looking at is the product toy launch infrastructure, and a product toy launch, a non-product one as well as here. So you can see that there's a step, and within this environment, so this is considered a logical deployment environments, right? So we can look at the environments as logical environments. It's not that representing the environment that we deploy against. Now you can see that there's a job that's been running in here, and you can see that exclusively to this, inclusively to this environment. You can click on approval and check, and you can see that there's approval that must happen, and that will time out after 30 days. But we can reduce that as well. And also you can add additional check things like branch control to do the merging, time specifics, or invoke some things like Azure function to do additional event, and it can invoke the REST API as well. So this can be very useful when we deploy against environment and we need some sort of approval or human intervention in the process. So let's get back to the pipeline. So it's still running and it's deploying, which is fine. So we can see that things are going well, and it will success eventually. And if we go here, we can see that there will be 3 instances running if I click on this, and you can see that there's a 3 instance of app services running here. All right. So if you look into the apps, so just one app, but there's 3 instances of it. All right. So, and that's set for me. So that's wrapping up the pipeline. So this is how you would automate it, your infrastructure deployment using Azure DevOps and Azure Pipeline. Thank you.